It is 8 a.m. on the West Coast. Hi, everyone. Thank you so much for joining us today. My name is Rafaela Kenny Sankata. I am the Senior Product Marketing Manager at Virtue AI, and I'll be moderating today's conversation. We're really excited to have you here because today's discussion is something many teams are actively wrestling with right now, and that is what it actually takes to secure AI agents at enterprise scale. At Virtue AI, we provide the first AI native security and compliance platform for enterprise agents, models, and apps. And our mission is to set the standard for advanced AI security with things like automated red teaming, real time guardrails, and comprehensive governance. Today's conversation sits right at the intersection of that mission and the real world challenges that security leaders are facing as agents become core to enterprise workflows. We're joined today by a pair of experts bridging AI security research and product development with real world security expertise. I'm excited to introduce Sunil Agrawal, Chief Security Officer at Glean. Sunil, tell the folks at home about your extensive experience in the security world and across Silicon Valley.
Thanks, Rafaela. Glad to be here. So, as Rafaela mentioned, the Chief Security Officer at Glean. For folks who don't know Glean, we started as a enterprise search company. I mean, we used to call ourselves the Google for enterprise. And then when ChatGPT was announced about November 2022, then we very soon launched our own chatbot. And then we used to call ourselves the ChatGPT for enterprise. You can ask questions and get back responses based on your enterprise corpus. Very distinct from what ChatGPT does. And of course, now the big focus is allow the employees of our customers use AI agents to make themselves 10x more productive. So the big focus is, of course, bringing AI to the workplace in every surface. So that's what Glean does. Been at the company a little over 3 years. Has been an amazing ride, as you can imagine. And overall, been in the security space, good 25 plus years. I say first 15 odd years, I was more a security engineer, very similar to Sanmi, more developing security products. And the last 10 years, I've been on the other side, more a consumer of security products. And of course, love every aspect of it. This is exciting time to be in the industry.
Absolutely. And we're so thrilled to have you. Thank you for being here. And of course, I'd like to introduce Sanmi Koyejo, co-founder of Virtue AI. I know Sanmi very well. Sanmi has lots of experience in the AI and ML space, both inside and outside of Virtue AI and inside and outside of academia. So Sanmi, if you could please tell the audience a little more about who you are and what you do.
Yeah, thanks, Rafaela. Really excited for this conversation with Sunil. Just engaging and thinking about agents and this move from more experimental research work to enterprise deployments and mission criticality and some of what this means. As Sunil alluded to, I've done a bunch of work trying to build AI safety and security infrastructure and research. My background is academic, so I've spent many years, most recently as a professor at Stanford University, leading Stanford Trusted AI Research Lab that works on building the foundations of AI safety and security. So measurement, mitigation, understanding deployments around these kinds of questions. I've been an academic for a while, a variety of different academic trinkets, things like the Presidential Award for Early Career Scientists and Engineers recently. And been really excited to expand from here to thinking about what this means for enterprise deployments. I spent some time in industry. I was at Google for some time, Google DeepMind, and a variety of other places. And yeah, we're really excited for this conversation, engaging in this intersection of sort of research, product development, real deployments for AI agents, particularly now as the sort of industry and the deployments are moving so quickly.
Fantastic. Great. With that, let's get into some questions. I do want to remind folks who are watching, feel free to jump in the chat and ask questions. We'll have time for Q&A near the end of the conversation. So definitely want to hear from you. You've got some great minds here to pick, so feel free to jump in the chat and I'll be sure to ask them at the end of the conversation. So we're talking about AI agents. AI agents have changed the rule book, the playbook, everything when it comes to security. Risks like jailbreaks, prompt injections, they simply didn't exist in the more traditional cybersecurity world. Sunil, as CSO of Glean, and someone who's been deeply involved in securing AI systems at scale, what fundamentally changes when we're dealing with these agents? What makes them so different?
Yeah, that's a good question. So the way I see agents, agents get data, they process data, they reason about the data, and then they take actions. In a way, I think about agents as more as applications. Now, and we have dealt with software applications, and we have a very mature SDLC process. Correct? What we used to do was we used to threat model every application that we develop. Then we would have tools like SAST and SCA, where all the code developed by the engineers would get scanned by the various security scanners. We would have some amount of runtime monitoring in the form of web application firewall and so on. And then, of course, we would observe the behavior, correct? So we would have all the application logs, they would get exported to a SIM. Now, that's what the world was for the last 20, 25 years. As we move to the agentic world, I consider them as applications. Certain things remain the same. You still got to threat model your agent. You still got to make sure that you have runtime security, and then you have observability of agents. However, the similarity ends there. If you look at the agents, in some cases, the extreme end, the agents are nothing but a giant prompt, which the LLM will look at, interpret, reason about it, and then take action. In some cases, those are workflows, but they no longer look like a software code that your developers used to write. So now you can't do a lot of static analysis that what you used to do because the agent specification is not rich enough. A lot of things happen during runtime based on the data it fetches. It reasons about the data and then decides what action to take. And it could be in an iterative loop. So the focus is shifting from doing a lot of static analysis to doing a lot more runtime analysis. The components are the same. The weightage has now shifted that you do a little bit of static, but a lot more of runtime monitoring. And then, of course, agents also produce a lot of agent logs, and you still got to observe those logs. So again, some components remain the same. The weightage distribution has changed. So we got to think about it slightly differently. So that's how I think about this entire landscape of securing AI agents.
Yeah, that's absolutely true. And then, Sammy, with that in mind, Sunil definitely touched on the fact of like that, having to secure at runtime is very unique. And
Mhm.
that, that attack surface is very unique when it comes to the retrieval, the reasoning, the tool calling. How are they different on a more technical level, that risk surface? How is it different than more traditional, or not traditional, earlier AI systems?
Yeah, it's super well said, Sunil, and I think that resonates a lot with how we think about some of these questions technically. I think, some of the big changes from both traditional AI security, but even say LLM security, include, I think, to your point, the attack surface really has exploded. Even thinking through most recently, where we're mostly engaged in questions around traditional AI security questions, you're mostly thinking about inputs and outputs and making sure you contain that behavior. Agents can do many more things, I think, as we've been alluding to. So interact with databases, APIs, email, payments, lots of tools because you give them access to tools because that's the point. And so vulnerabilities are no longer just bad outputs. They could be unauthorized database writes. They could be fraudulent transactions. They could be sort of mistakes and various kinds of actions in the real world that can meaningfully impact real systems. I think one big challenge that's shown up is that errors compound across multiple steps. Again, to some extent, this has been true for a long time, but I think the macro level of what steps are, I think, has become much more complicated, and I think is part of this explosion in the threat surface. So when an agent makes a decision, very easily it can cascade into a bunch of subsequent actions, either for the agent or the rest of the tooling system around it. Some misinterpretation of an early multi-step workflow can lead to a bunch of failures. Easily, these can spiral out of control. And because the whole point of agents is to avoid humans in the loop, you have this trickiness of these errors spiraling without necessarily humans in the loop to try to contain them. And then a third uh, part of this, and I think this is borrowed from a lot of the LLM work, is this contextualness that Sunil alluded to. So agents, process vast amounts of information. They're not doing this over long conversations, complex workflows. This allows attackers and bad actors to hide malicious information or instructions very deep within the information deluge is coming in. So deep in email threads, deep in documentation, deep in tool responses, where you have various kinds of indirect prompt injection issues that are just harder to detect than they would have been in classic security, computing security, but even more so classic AI security kinds of workloads. And so, you have agents that will follow commands and potentially even embedded commands because it's hard to distinguish these legitimate contexts from potentially malicious manipulation. And as we'll talk about a little bit, I think this is some of the places Virtue AI has spent much of our time investing. We've built Virtue Agent to engage in the fact that the threat surface has exploded and you have this sort of highly contextual kinds of risk surface and attack vectors. So thinking about action level guardrails, thinking about the MCP server, if you're going to use MCP for agent deployment, and potentially scanning, we built MCP guard for this. Red teaming, to Sunil's point, about realistic deployment issues. So having sandboxes that you can evaluate what these agents might look like and the security risks in the real world. I think these are some of the technologies we've been deploying to engage with this emerging risk surface that comes from AI agents.
Yeah, absolutely. I mean, it is really amazing. We're watching security like evolve right before our eyes very fast. And as things change, security teams need to be nimble and adaptive. Sunil, as the chief security officer, strategy is key. And, like you mentioned earlier, many security teams had built their programs around these more static tools because that approach worked well at the time. But in your experience, where do those traditional security tools start to fall short? Where does the strain start to happen when they're dealing with these agentic systems?
Yeah. So I would say again, I'll go back to how our entire SDLC process was, which was a lot more skewed towards, static analysis, do things. I mean, of course, shift left. We have heard that term, correct? And the industry has put in a lot of effort to do shift left. Great initiative, correct? Fully supportive. However, with agents, the amount of shift left you can realistically do reduces. Not that that's not a great idea, just that you cannot because the agents are very, very dynamic, correct? I mean, as I was saying, you open up an agent specification that will appear really thin at the beginning, but then everything unravels, correct? As the you execute the agent, it gets access to the data. The data could be from your internal corpus, could be from your database, could be from web searches. And then based on what data you have fetched, now the agents, as Sammy was describing, goes through evaluating the data, reasoning about the data, planning, and then deciding what action to take next. And then there is this agentic looping. Then it would just iterate over this thing till it achieves the overall intent. So a lot of it happens during runtime. Most of our security tooling, as I've been saying, was more front loaded. But now you got to be during the runtime, actually when the action is happening. Now, this is where the entire tooling needs to evolve. Correct? We need a lot more runtime security guardrails. We had some of that. I'm not saying that, the concept of web application firewall, network intrusion detection, correct? We had some amount of runtime uh, guardrails, but now the breadth and the depth of runtime guardrails are just going through the roof, correct? Because it has to be, as Sammy was talking, the stuff that Virtue is doing. You have to look at every data that comes in, every planning process, every action is about to take. So the action guardrails, correct? Now action could happen via native API integration or via MCP. Everything needs to be looked at runtime. Observability is great, but that's after the fact, correct? If you want preventative measure, you have to be in the path and you have to have very deep knowledge of what's going on. You cannot be at the network level. No, that does not give you enough insights. So I would say that is the shift that needs to happen in the security tooling.
Yeah, that's spot on. And I think you kind of mentioned in there, and Sammy, I'd like for you to jump in here because we're kind of talking about AI native security, right? And this is a term that's being thrown around. In concrete terms, and I'm a marketer, so in more concrete technical terms, what does AI native actually mean when it comes to security, and how is that different from just taking an existing security tool and kind of retroactively, attuning it to Gen AI workloads? What makes AI native so specific?
Yeah. So at Virtue, we think of AI native security as the security system itself is using AI tools to understand AI threats and mitigate and block threat vectors and threat actors from affecting AI deployments and leading to bad outcomes. So if you want a sort of one-liner or snippet, it's using AI to secure AI systems. As we've already alluded to, and I think Sunil has given us a great sort of script about traditional security, but in lay terms, you're looking for things like patterns, keywords, known attack signatures. This works well for things like SQL injection, cross-site scripting, some of the traditional computing security kinds of issues. But they don't, these kinds of approaches don't work well when you have AI-specific threats, things like jailbreaks, prompt injection, as we were even talking about, various ways of agents potentially making mistakes in sensitive operations, because the patterns now look quite different. So again, context ends up mattering a ton. You now have semantic issues that manipulate meaning, context, reasoning that attackers can take advantage of in trying to manipulate the way the systems behave in the real world. And so the AI nativeness is, again, developing AI tools that themselves can exploit this knowledge of context and adaptiveness to meaningfully secure AI systems that, again, have these increased capabilities and this increased adaptiveness. So at Virtue, we engage in this by building specialized models that are purpose-built for security risks. We've built a variety of different tools. We spend a lot of effort on making sure these tools are highly effective and highly efficient, so they don't slow down your deployments. So we talk a lot about efficiency and latency. We build guardrails that have sub 10 milliseconds latency, that have quite meaningfully lower footprint on in terms of actual say model sizes than most of the other things on the market. This allows you to scale the security infrastructure to make sure that, again, it's not the bottleneck to productive AI deployments, and particularly AI agentic deployments. So in terms of the way this shows up in the sort of enterprise, I think some of the key distinctions include, to Sunil's point, continuous adaptive testing. So we're not doing this as sort of point-in-time assessments. We're continuously red teaming agents and continuously guardrailing agents as they evolve and as they get deployed. We are understanding better what the new kinds of attack scenarios that can show up and how contextual they can be. We're engaging deeply with the frontier AI system developers to understand new threat models as they emerge, so we can sort of continuously adapt our systems to make sure that we're keeping up with the bigger, more complicated new kinds of threat vectors. And then maybe I'll just throw this key point about, I think, this emerging multimodal landscape that's evolving. I think some of where I expect a lot of the agentic workflows to go is going beyond just text. We've already seen code which is text, but it's its own specialized kind of text. It's in some ways its own specialized language, but where that can be part of the threat vectors. And so we're building toolings around code security, images, audio documents. Again, if agents are going to be able to access all these kinds of information and be deployed in these kinds of complex scenarios, we need tooling that can engage with these, again, much more complicated contextual kinds of deployments. And so on our end, at Virtue AI, we're building tooling that can engage with, again, this highly contextual, continuous, and adaptive emerging AI agentic world. I think the frame has meaningfully changed, and AI nativeness now looks like building systems that are themselves AI systems built, purpose-built for mitigating security issues.
Yeah, absolutely. Sunil, I want to actually kick that over to you because I do think the multimodality is so interesting. Just as talking about, what you're doing at Glean, I mean, you couldn't get more multimodal, right? These agents are touching everything and anything. If you want to just add any additional thoughts on kind of the unique challenges to multimodality specifically, because it's a little bit of everything, clearly.
Yeah, and in the enterprise, we see, of course, we all started with text. Right? We got to deal with images, and of course, code, correct? I mean, that's everywhere, correct? And we are, processing code, understanding code, generating code, correct? That brings in a slightly unique set of challenges compared to natural language. You know, we are all providing audio interface. We want to understand audio so that we can transcribe it, correct? So that we can extract the meaning out of it. So yes, multimodality is there, and this is being used in the enterprise today. And of course, that has its unique set of challenges. Just talking about images, something as simple as images, the kind of things that you got to worry about, all the steganographic techniques, which was used to hide information, now it can be used to leak information. Correct. So now you got to be monitoring for those things. We have seen images could contain prompt injection attacks, correct? Not just text, they could contain text and they could modify the behavior of LLMs. So we have to worry about, all of that, correct? Because all those modalities do exist in an enterprise. So absolutely. And the
Exactly.
only way to solve that, to going back to what Sammy said, is you got to use AI to solve the problems created by AI. There's absolutely no way. Your regular expressions, your pattern matching is absolutely not going to work, correct? And plus the pace at which things are happening uh, is again, you need AI or automation to make sure that you can handle it, correct? None of the manual mechanisms will work. So completely plus one to everything that Sammy said about, AI native security.
Yeah, absolutely. So true. So we've talked a lot about the tech, but this kind of rapid explosion of agents has also, and AI in general, has really changed the people who work in security, right? Um, Sunil, like in the market, many people believe that AI security can't be solved by just cybersecurity expertise. Why is deep AI and machine learning expertise now kind of become an essential when you're thinking about people you want to, use to help secure Glean?
Well, you got to understand what you're trying to secure, correct? I mean, and this is not as simple as, doing the phishing attacks and so on, that, you look at, these are the various markers. No, I mean, you got to understand how LLMs work. Only then you know why prompt injection is a real attack, why jailbreaking is a real attack. You got to understand how agents go about reasoning and do multi-stage planning, correct? And then decide what action to take. Only if you understand that, then you know you got to do action to agent alignment, correct? And what are the subtle things that could go wrong and you got to prevent. So I would say it's completely inherent because without knowing, first of all, how AI works, you don't know what you're protecting you against. So that's very fundamental. The second thing is, again, as we just were talking about AI native security, once you understand what you want to protect, what are the tools available to you to protect? And again, we talked about how the old ways of doing things will not work. You cannot create static policies. You cannot create regular expressions or your patterns. Why? Those things are no longer relevant in this space. So you got to understand what tools are available, what are the capabilities, and why do you think those tools are the right set of tools to solve the problem? And on both sides, there's a lot of AI. And not just even, I wouldn't even say the classic AI, the old machine learning models. I wouldn't even say those regression models. No, you got to use, you know, even your past deep learning. Now you have to use transformer-based technologies, you got to use either LLMs or SLMs, the way Virtue is creating, because you got to understand things at a semantic level. Correct. So I would say there so many things have advanced that you got to understand both the sides, and AI is the answer to securing AI. Absolutely.
Absolutely. So well said, Sunil. So well said. Sammy, it's funny at Virtue AI. I mean, we talk about AI native security, but it's funny, we kind of have an AI native team as well. Our founders all come from deep AI security research backgrounds. Tell me about that foundational expertise for maybe people watching who aren't that familiar with, the team's accomplishments and how that influenced what you then built at Virtue AI.
Yeah. So to your point, Rafael, myself, Bo Lee, Don Song, Carlos Gestrin, individually we have over a decade, and for some of us multiple decades of experience in AI research and specifically AI security research. So I think to Sunil's point, we're doing some of this stuff before it looked like generative AI. We were doing adversarial robustness kinds of work on classic predictive AI systems. Bo and Don did some of this early work where you'd put stickers on stop signs and get image recognition systems to incorrectly recognize them as, say, a speed sign, which could cause issues for self-driving cars, which I think had a big impact for a while and still does. But thinking through the robustness of AI systems deployed in the wild that power lots of technology. Collectively, we've published hundreds of papers on various aspects of adversarial machine learning, trustworthy AI, measurement, security evaluation. And all of this experience, I think, fundamentally shaped how we think about AI security and the foundations that built Virtue AI. I think some of the ways that this shows up. First, we think a lot about measurements. And rigorous measurements. I think some of this comes from both academia, but also how it translates to real deployments and deployments that enterprises can engage and trust. So a lot of this work is, thinking beyond ad hoc security testing to build technology allows you to systematically evaluate your AI deployments across calibrated risk categories, and building tooling that allows you to have audit-ready evidence for the security of your AI systems. And we believe that this scientific rigor on measurements allows better confidence, and particularly for CISOs have more confidence that they're seeing closer to the complete picture of what they should expect and real AI deployments. So, beyond anecdotal testing, understanding something about what to expect in real world deployments. Second, to Sunil's point, our research allows us to engage very deeply in building technology specifically focused on security risks and security mitigation. So we developed a variety of different models that are purpose-built for these kinds of tasks. We've talked a bit about the guardrail models. We have some more recent work on vulnerability testing for coding and other kinds of AI threat vectors. And we've shown how purpose-built specialized models can actually significantly outperform much bigger models compared to, say, even many of the large frontier models that are billions of parameter plus. And because we're building purpose-built models, again, we can make them much faster, much more efficient, while still getting much better performance. And again, we've quantified lots of this. We've shown 30x speed improvements while still beating in performance in a variety of different deployments. So this allows us to deliver comprehensive protection without sacrificing latency and other systems requirements that are necessary to actually get AI to have meaningful positive impact in production deployments. And then finally, I think a lot of what we're seeing right now is that the threats evolve very quickly. And I'd almost say that AI threats are moving at research speed beyond, traditional insecurity, there's work on CVEs to engage in documenting potential threat vectors. But the tools themselves are evolving so quickly. And I think aligned with that, the threat vectors are also evolving so quickly. So we engage at the frontier of knowledge. We engage in places like NeurIPS, engage in academic conferences to understand emerging attacks before they hit production systems. We engage in many of the frontier AI development companies. So, your OpenAIs, Anthropics, and many of these other companies to make sure that we understand these threat vectors early before they hit broad system deployments. And because of this, we can update our platform continuously with new attack vectors and make sure we're building defenses that can adapt to sort of cutting edge deployments and cutting edge research as we learn new things. And so, to your point, you were asking about people. I think, again, understanding deeply the foundations of building AI allows us to remain at the frontier, to go beyond, just what looks right, but actually engaging with fundamental mechanisms to make sure we can build secure AI systems at scale.
Yeah, absolutely. Actually, one thing that Sammy mentioned that I'd love to just this is me selfishly wanting to pick Sunil's brain here. The kind of small model versus large model debate, there are pros and cons on both sides. I'm curious, just, super high level, but yeah, what do you think about that as far as, the right place and time to employ a small model versus a large model and kind of how maybe a small sharp knife is good for some things and a big axe is better for others, I suppose.
Yeah. And again, that's a very good question. So as I was talking about how, when you look at the security of AI agents, you got to look at all the three aspects, correct? And with a big focus on the dynamic runtime security. Think something where you are in line, correct? Not after the fact. Now, in order for you to be in line, where you are looking at every communication that your agent is doing with LLM, or every response that you are receiving from LLM. Similarly, every action you are taking, every communication your agent is doing with MCP servers or so on, everything needs to be inspected, correct? And that a single agent could have, you know, uh, tens to hundreds of interactions with the LLMs and also interactions with the various external systems. Now, everything needs to be inspected in line, real time with the ability to block, correct? You do not want to
Hmm.
leave things to be after the fact. What that means is latency is a very, very big consideration, correct? So now if you were to use LLMs, you know, they may work at the same level as SLM, but the latency is going to be really high, correct? That's one. The second is, a lot of the foundational models, you don't, the kind of space we operate in, what we do is we provide a single tenant for each of our customer. Now we can't be deploying a large language model in each of our customer. That's just going to be super expensive, correct? And we don't want to make a network call out to GPT models, correct, every time, correct? Because as I said, there will be hundreds of calls for a single agent execution. We can't be doing that. Okay. So what we need is that model to be running within the customer's tenant next to the agentic application so that not just the latency, correct, the form factor also matters because you got to look at compute, correct? I mean, again, in the enterprise, everything matters, correct? You need to think about security, you need to think about performance, user experience, cost, all of that. So it's those things, that's where exactly, that virtue steps in, that, hey, you have those constraints to make any kind of AI security a lot more practical to work in the real world. And that's where the SLM versus LLM debate is a very good one. And I feel SLMs purpose-built language models for a very specific purpose. That's where, they have found the right niche.
Absolutely. I actually wanted to zoom out a little bit and now talk about the enterprises themselves, right? So, Sunil, you've kind of had a front row seat to see how enterprises are operationalizing AI. What sectors specifically do you think are kind of leading the way on AI security adoption, or which ones do you foresee leading the way on AI security adoption?
I, I would say I'll answer it slightly differently as to which industries I see
Hmm.
are leading the way in AI adoption. Correct?
Right.
And then that would dictate, which are the industries
Naturally.
that need AI security, correct? And I would say so far, I've been very, very pleasantly surprised. It's been the entire spectrum, correct? I mean, of course, Glean started in Silicon Valley. Our initial customers were more the Silicon Valley tech companies, obviously, correct? Just because of the geographical proximity. But over a period, what we have seen is we have customer in the tech industry, the healthcare, the finance, the legal, the entire spectrum. We even have customers, who have been around for more than 150 years. So, the pace, this is even more pleasantly surprised than the movement from on-prem to cloud. When that happened, that again was a mandate, top-down mandate that you got to move. But however, we saw certain companies being very cautious, correct? And they did not want to move to the cloud because of security, privacy, compliance reasons. With AI, I'm not seeing that resistance at all. Everyone is leaning in. The promise is amazing, and everyone wants to make sure that they're adopting AI, okay, across every industry. You can think of the most conservative industry, maybe it's the healthcare, maybe it's finance, or legal, most heavily regulated industry, and you will see that they are adopting AI at an alarming pace, which has been very surprising. And of course, the companies that are adopting AI, and hence, of course, they want to adopt it in a safe, secure manner, as we all know. Uh, Gone are the days that you can sprinkle the security pixie dust, later on. And it has to be thought about day zero. So those are the companies that, hand in hand, I would say, as they're adopting AI, they're adopting AI security.
Yeah, absolutely. It's 8:35. We're going to stretch to 8:45. I encourage anyone watching, if you'd want to jump in the chat and ask any questions, we'll open a Q&A in a moment. I still have some more questions though, but do want to encourage anyone out there in cyberspace to jump in in the chat there. Um, I did want to talk a little bit about, uh, actually, let's talk about a specific agent attack that is kind of interesting. The Virtue AI team recently demonstrated an exploit chain where basically MCP servers like Gmail and PayPal were prompt injected into a fully automated financial transaction. Basically, the agent, was corrupted and able to move through Gmail, PayPal, and basically execute financial transactions independently, which is obviously a very scary thing. Uh, Sammy, and then Sunil, you can follow up as well. Why is this class of exploit, particularly dangerous? With the exception of the obvious of, you don't want someone spending money on your credit card. Why is this, so alarming, for folks, and what makes it, unique to agents?
Yeah, so I think this exploit, I think it alludes to some of what we were discussing at the beginning, where agent deployments touch so much more of the infrastructure. I think what's interesting about the MCP exploit is that it's not about attacking the model per se directly. It's about attacking the MCP layer, which is thought of as infrastructure and not as directly about the model. So, traditional jailbreaks, you're trying to manipulate outputs with clever prompting. Now you're able to manipulate somewhere else in the infrastructure contextually in such a way that, again, you can cause meaningful, maybe serious issues in getting agents to do things that you would otherwise prefer not. So cause serious security gaps. So in the work that we showed in this MCP exploit, again, all the models worked as they're supposed to. GPT-4, Claude, Gemini. The vulnerability was actually, although the exploit was about architectural trust, not necessarily about sort of model weakness directly. So, agents are designed to trust their tools, they're designed to trust their data sources. And, when MCP server provides information, the agent is not supposed to, or traditionally would not question, traditionally again, in how quickly the world is evolving, but would typically not question his legitimacy. And so the exploit embedded malicious instructions and email metadata that would be routine data that agents would process continuously. And these instructions are able to propagate through a system and cause various kinds of issues. I think another important thing is that this exploit was agnostic to the model and vendor. So this is important because I think sometimes people imagine that the protection might come from again, often in traditional security, exploits are often specific vendor specific. And so you're worried about maybe exposure because of whether you're using the same vendor that was attacked. Here, we're showing that many of these exploits are quite general and work almost independent of the vendor that you're using, as long as, again, these vendors are built to solve these kinds of agentic tasks. Because here we're targeting, essentially the retrieval augmented generation system that's meant to help you deploy at scale to solve real-world agentic tasks. And so any kind of context that the agent consumes is potentially vulnerable. And so the sort of, I'm going to upgrade my model, or I'm going to switch provider to say to get around this issue doesn't work in this case because these kinds of issues are, again, general purpose and not that model specific. Our demonstration, we showed that a simple single compromised email can lead to unauthorized transactions, in our case through PayPal. But you can imagine, and we've shown that these same kinds of techniques apply to any tool call that the agent can make. So again, this shows up for database writes, cloud infrastructure commands, API calls. I talked at the beginning, I've discussed a bit about this just increasing explosion of the threat surface. And I think this shows a good example of this, where you can control the agent's decision making via the context stream, and I think interesting new ways. And then finally, I think this, to our earlier conversation, this kind of attack will be invisible to most kind of traditional security monitoring because, again, the attack payload lives in seemingly legitimate context. It lives in email, and the traditional, or at least the obvious markers of security flaws in email would not show up here. And so particularly for an agentic deployment where the agent is following instructions and the agent does exactly what it's designed to do, it retrieves context, it acts and runs on it. But again, this creates meaningful security vulnerability for the agentic deployments. So yeah, I think this is something we think about a lot. Again, the point here was to show that these vulnerabilities exist. We built MCP Guard to show and detect and mitigate these kinds of issues in the MCP part of the infrastructure. And as mentioned, we've built sandboxes to understand what these threat models look like across the entire AI agent tool chain. But to your point, yes, I think these kinds of threat models really meaningfully explore the explosion of risk surface for modern AI agents.
Yeah, and then Sunil, kind of from the CISO perspective, one of the things I love about security is often security practitioners are former military or they've kind of been in the trenches of security and really seen it all and have these war stories. So I'm curious from your end, as much as you can tell us, with Sammy's story about the MCP server exploit in mind, do you have any kind of rogue agent tales that you can share with us that kind of would even make the most military hardened or security hardened CISO kind of take pause?
I mean, luckily not yet, correct? I mean, and we want to keep it that way, correct? But of
Yes.
course, if I can extrapolate, everything that Sammy was saying, this is something that we have been definitely been talking about, correct? We know that this kind of attacks will be possible. Great that Virtue, brought everything together and showed, because nothing speaks better than a POC in the security world, correct? That I have a working exploit, correct? So this is nothing theoretical. It can be done. Plus, I think to make, just to elaborate, I have not looked at this particular thread, but the way Sammy was describing, I would imagine that I don't have to do anything, correct? This is the email that just came into my inbox, correct? So it's not that I am being phished. I'm actively doing something. No, an email just came in my inbox and that just triggered everything, correct? So it's zero click. That's scary, correct? The next thing is, how do I go about protecting it, correct? Because as Sammy was saying, hey, my immediate reaction is, hey, maybe the model should have protected me. Let me upgrade the model, correct? No, it's not a vulnerability in the model. It's not a vulnerability in the MCP protocol itself. Potentially, it's not even a vulnerability in each of the Gmail and PayPal MCP servers. It is the agent, and maybe its agent's memory got corrupted because of the data it ingested, correct? And that forced it to act incorrectly. So the thing is, you got to look at everything and holistically, end to end. Only then you'll be able to secure. And this is where I think, Virtue is also saying the same thing Sammy has been talking about, that everything has to be looked at it in cohesion. You cannot split it apart and say, okay, I'll just upgrade this component and now I'm secured. No. So I assume that there will be some more horror stories around agentic insecurities in the next 12 to 18 months. And of course, that is our responsibility, both, Virtue as a provider of security tools and me as a CISO, as, consumer of those tools, that we reduce the number of such occurrences and the possibilities.
Absolutely. So we are nearing 8:45. I want to thank both Sammy and Sunil for their time. I have one last question. Chat is still open if anyone wants to ask any questions, but I certainly have one more. I would love for each of you to just share one kind of brief key takeaway that you would want for this audience. Given this conversation, we've kind of touched a lot of different topics around agentic security. Is there any one key takeaway that you would like to share? Sunil,
So,
we can start with you.
yeah. So I would say agents are really powerful. They can make you 10x productive. Definitely lean in, adopt because it could have, very asymmetrical gains if you get things right. However, do not leave security as an afterthought. Bake it on day zero so that you can adopt and get all the advantages of agentic AI in a secure, compliant manner.
Absolutely. Yeah, it's funny. So many folks think of security as the last mile when it really should be
Mhm.
the first.
Yeah.
Sammy, your key takeaway for today.
Yeah, so maybe great minds. I had maybe very similar, security should not be an afterthought. Maybe I'll add a little bit of a nugget. I think even more than not being an afterthought, I think security could be an accelerator. And I think this is a very productive way. And this is how we think about it at Virtue, is that, again, if you're going to get productive, real world, useful sort of outcomes from AI deployments, beyond just thinking of security beyond an afterthought, but about how you're building, really you can think of security as helping you accelerate your building so that you can actually get to these positive outcomes faster. And again, talk about this when we talk to enterprises. Deploying agent safely and confidently and doing this with security built in will actually, we believe, help you to deploy faster than your competition. Removing risk barriers that holds other people back, and building in security will allow you to innovate faster and remove some of the obstacles that often block deployments right now. And so, we think to some extent this is a fundamental mindset shift, again, beyond the classic security framing as how we normally think about this. But we think this accelerator perspective actually is productive and can be one that many enterprises can run with. And to that end, we're building tools. We've again shown that these kinds of tools can work at enterprise scale, and very grateful to be partnering with Glean and engaging in and thinking about these kinds of deployments at scale. Thinking through many of the existing frameworks and making sure that we can protect against these kinds of emerging threat models. And maybe I'll just encourage not to wait for security incidents to force action or let security bottleneck your deployments. Again, building it in as part of your capabilities, we think, can help you accelerate much faster and actually become an accelerator for your AI deployments and AI agentic deployments in particular.
Absolutely. I love that point about security being an accelerator, not a decelerator. The greatest kind of analogy I've heard is if I gave you a car that had no brakes, you wouldn't drive it very fast. You'd be terrified. If I gave you a car that had great brakes, you'd be in NASCAR. So I just want to thank Sammy and Sunil for such a candid discussion. This is exactly the type of grounded, real world conversation that security leaders need as AI agents move into production. As Sammy said, we're excited to promote our partnership with Glean. Together, we're bringing AI native security and compliance directly into Glean's enterprise environment. And Glean has always taken a really thoughtful, rigorous approach to AI security, particularly around evaluation and reducing things like hallucinations, which makes it such a strong fit for partnerships. So thank you to Sunil, of course. And if anyone watching wants to dive deeper, you can learn more about our partnership, about Virtue AI at virtueai.com. I'll also be following up with links and materials after the session, so check your inbox. And yeah, thank you so much. I hope everybody has a lovely day and farewell. Thank you so much.
All right. Thank you.
Thanks, Rafaela. Thanks, Sunil.